I'm going to make a bold statement at the beginning of this tutorial. I am going to say, where have I gone? I'm going to say the following things. Get ready for this, folks, and get ready to disagree with me. I encourage you to disagree with me, or try to at least. I'm going to say that all human movement, and I'm talking about sort of skeletal muscles here, you know, the things that happen at joints rather than like churning of the stomach or something. All human movement occurs in a circle or a part circle. Oof. Do you agree with that statement? If you do, fantastic. If you don't, I would like you to move any joint of your body without making a circle. For example, try moving your head forwards and backwards without making a circle or a part circle, or side to side, almost like turning your head. Or take your shoulder and flex your shoulder in front of you, or put it up in an abducted position, or put it behind you in an extended position. You are making a circle or a part circle. In other words, all human movement occurs in a circle or part circle. And that's because human movement is based on the principles of leverage. And that is exactly why we're studying this particular topic. Now, with that in mind, and a little film reference for you, you're too young to watch this film, I'm going to make it anyway. Let me introduce you to my little friends. I have got here one, that meant to be further on. I've got here 1, 2, 3, 4 little mates that are going to help me here, right? I've got 4 little mates, and I'm going to sort of prove this point to you. And I'm going to introduce you to what can only be described as an absolute beefcake of a photo. And what I'm going to do with this photo is I'm going to kind of just shade it out a little bit so it's like that. And what I'm going to do is I'm going to start moving my little friends, okay? So I'm going to drag this thing here, which I'm going to call a lever arm, and I'm going to put it there. I'm going to take this little fella here, and we'll start naming these in a second properly, don't worry. I'm going to take this little fella here, and I'm going to put that just there. And I'm going to take this little fella here. I need to stop saying the words little fella. I'm going to take this square, and I'm going to put it there. And I'm going to take this little arrow, and I'm going to put it, boom, right there. Okay, now, what I want you to be thinking about here is that I have just made, or at least illustrated, a lever. And I'm trying to make the point that all human movement occurs as a form of leverage, as circles. And in this case, what's going to happen in this situation, we're imagining that the movement is in an upwards direction. In fact, we'd actually call it anti-clockwise, but let's call it upwards. And what would happen here? Well, of course, as this sort of dumbbell was raised upwards, we would effectively get this action here, which would be a flexion of the elbow. We would lift the dumbbell. That's what would happen. This is a lever. How do we know it's a lever? We know it's a lever because, number one, it's got a lever arm. Now, that's the line. In the human body, this tends to be a long bone. So in this case, we're literally talking about the radius. Number two, it has a fulcrum. Now, the fulcrum is that little triangular bit, and in the human body, this is typically a joint. In my case, that's the elbow joint. Number three, it has an effort, okay? An effort. And the effort is always a muscle or a muscle contraction, specifically the muscle contraction that is applied to a bone. And you see here, I've got my bicep muscle here. It's not mine, by the way. That's coming down and inserting just there onto the radius. Now, it doesn't matter the detail of this. My point is the effort is pulling up, boom, in that direction like that. And fourthly, guys, we have something called a resistance. Now, be ready because you will hear the word load used interchangeably. I will probably use it. Resistance and load are synonymous terms. So in this case, that resistance and load tends to be the weight that we're lifting. It could be the javelin that we're throwing. It could be our body weight, which we are overcoming, something like that. It's the thing that we are trying to shift, for want of a better term. And once we've got those things, we have got our lever. And by the way, there are 3 types of levers. In fact, there's many types, but we classify them as first, second, and third. And all have their strengths and weaknesses. These are, sorry, I should have put the word class here. First class, second class, third class. And we're going to look at that specifically. And I'm going to show you what makes a lever a first, a second, or a third class lever. Now, if I was to tell you, for example, that this one here is a third class lever. Now, I'm just going to leave that hanging for now. And once we've looked at others, perhaps you'll get the intuition of why this is a third class lever. Okay, Let's get down into classification. Oof, that's a bit bright. I've got 2 photos here. Now, before I draw anything, I'll go over this. I just want you to notice what is equivalent. Find, please, the equivalence in these 2 levers. We have got neck extension, effectively looking up as if, volleyball setting, or maybe you're heading a football or something. And we have got here a badminton player who is going to extend their elbow. This racket is going to come into this direction. What do you notice that is equivalent about those 2 levers? And I'm hoping you would be able to say to me, James, the fulcrum, listen to these words specifically, the fulcrum, the triangle, is between the other 2 components. Okay, so the fulcrum is between the effort and the resistance. The fulcrum is between the resistance and the effort. That is what defines our first class lever. Okay, and that is because we use a system which is for, if I write it in here, for 1, 2, 3, in other words, for first, second, or third class levers. Think F, L, E. In other words, if the fulcrum is between the other 2, it makes it a first. If the effort is between the other 2, it makes it a third. If I go back up here, look, what have we got here? The effort was between the other 2, it makes it a third class lever. That's how we can classify these levers. So let's have a look at this. Let me look at the elbow extension perhaps as the first example. What do we have here? Well, we have a situation where the elbow joint is the fulcrum. Brilliant, that's great, and that's got to end up between. But what's kind of interesting about this is it's actually the tricep muscle here, which is going to pull just here on the very end of the ulna. It's got a name, it's called an olecranon, it doesn't matter for now. But right on the end of the ulna, just there, and as it pulls in this direction, it's going to kind of bring the arm round, the elbow round in an extended position. Of course, we've got the resistance, the load up here, the weight of the forearm, plus the weight of the racket, plus I suppose the strike of the shuttle. Therefore, we have our first class lever. In this case, what do we have? We have our fulcrum of the neck. It's actually called the atlas and axis joint. We won't get into that here. We have the neck muscles. We could name them. They're actually called, there's one called the scalenes, and one called the sternocleidomastoid. Doesn't matter for now. But those muscles are pulling down on the neck. And of course, we've got the weight of the head. And by the way, the weight of the head is actually quite forward. I don't know if you've ever noticed this, but the weight of the center of mass of your head is not sort of in the middle of your head, it's slightly forward in your head. So of course, we've got the resistance on that end. We have got the fulcrum between the other 2. We've got a first class lever. Now, if we take this further, I've got the same example expressed in 2 different ways here for you. This here is what we're going to think of as a second class lever. A second class lever. Now, you should be able to see it's a second class. Why? For 1, 2, 3, think F-L-E. The load, the resistance. In fact, actually, it would be a good thing for me to do, say, for 1, 2, 3, think F-L or R-E, because you guys tend to use the term resistance, but resistance. So the resistance is between the other 2 points. But look, let's think about what we've got here. We've got the fulcrum, which is effectively the ball of the foot. Okay, and what we're going to do here is imagine this person is going to kind of spring upwards like this long jumper is. Look, we've got here, we've actually got the full, let me go for a darker colour. Here, we've got the fulcrum there. That's probably not as dark as I was hoping for. We've got the fulcrum there. Now, the resistance is the weight of the body. Now, interestingly, the weight of the body acts downwards through the tibia, so we've depicted it just there. So in this case, we would have the weight sort of here. We would have the resistance there. And of course, then we've got the effort. Now, what is this effort? Well, this effort here is the pulling of the gastrocnemius via the Achilles tendon onto the heel bone. So in other words, this muscle here is pulling here, and it's pulling in that direction. Therefore, we have got our lever. And of course, there's the lever arm in there, which is the bones that make up the foot. We have got our second class lever. The second class lever is brilliant at moving heavy weights. That's what its job is. I'm not going to get into describing that in detail, but that is its job. And then, guys, finally, if we get back to our third class levers, I mean, we've already done this, haven't we? Have a look at our third class levers, and I'm going to give you a bit of intuition to leave you with. Notice here what we've got. We've got our resistance, which is the weight of the dumbbell. We've got our fulcrum, which is the elbow. And between those 2, as we've said, we've got our bicep muscle pulling on the radius in that direction. What happens? This will curl upwards. That, therefore, is a third class lever. It is a third class. Why is it a third class? It is a third class because the effort is between the resistance and the fulcrum. Now, before I leave you with this, I just want to make a point. Levers, if I go right back to the top, levers are different even if they're the same classification. Let's imagine a situation where someone had a really long forearm. Okay, let me just go back to here. If I was, for example, if I was to get this, let's just imagine this person had really weirdly long forearms. What would happen, of course, is this load would be like this resistance would be right over there. That changes the nature of this lever. Okay, or for example, let's say we had a different third class lever, and it could be that the dimensions and the distances between these two things would be very different. For example, in knee flexion, that would be the case. I'm not going to get into it here. The point I want to make as a general point is that your joints are specifically, air quotes, evolved, designed. Your joints are specifically positioned, placed, structured to perform the exact roles. And if I was to get very philosophical about this, one's capacity to produce certain sporting techniques, powers, is largely based on the interaction of these components. Now, I'm not going to get too heavy about it, but those are things when you get deeper into the subject that you can really, really think about in both a practical, scientific, and even aesthetic perspective. I'm going to shut up now. Thanks for listening.